All right, today we're looking at solving trig equations. It'll be helpful if you have a unit circle to reference as you go through some of these problems. Certainly as you do the homework, you'll need it. On the quiz next Thursday, I will provide a unit circle. So you do not need to have the unit circle memorized, but as we go through this, you'll see that you do need to know how to use it. So we're really just going to look at solving equations using trig functions. We will do one problem on unit conversions, basically. So, solving trig equations. If sine theta is 1/2 and theta is between pi over 2 and pi, what is cosine theta? So first off, what do we know? We know sine theta is 1/2, and we know that theta is between pi over 2 and pi. So this part tells us that we are on this portion of the unit circle, right? Pi over 2 is 90 degrees, pi is 180. So the angle we're dealing with is between 90 degrees and 180, or in radians, pi over 2 and pi. So you can just look at your unit circle, sine theta is 1/2, that's the y value. Where on this section is the y value 1/2? And you could look and see that that's happening when theta is 3 pi over 4, or no, it's not. It's when theta is 5 pi over 6. And we're not asked for theta, we're asked for cosine theta, and at that point, cosine theta is police car, negative root 3 over 2. So that's what I'm meaning when I say you have to know how to use the unit circle here. You have to be able to read this, interpret that sine theta equals 1/2 means the y value is 1/2, and then read this because there are 2 points on the unit circle, one here, where the y value is positive 1/2. This is what's telling you which one of those to go with. And then I'm asking you for the x part. So then here, theta is between 0 and 2 pi, including both. We need spots where tangent theta equals sine theta. So you just have to remember that tangent theta is y over x, and sine theta is just y. So what points are going to make y over x equal to y? Those would be points where x is 1, because if x is 1, then y over 1 would equal y, or points where y is 0, because if you have 0 over something, that'll equal 0. So when is x equal to 1? That would be when theta is 0, or when theta is 2 pi. And when will y be equal to 0? At those 2 spots, as well as at theta equals pi. So all 3 of those would work. And again, you're seeing that you don't have to have the unit circle memorized, but you do have to be able to use it to figure some of this stuff out. Okay, same argument here. We've got 2 cosine theta is root 3. Get cosine theta is then root 3 over 2. Between 0 and 2 pi, where is cosine theta equal to root 3 over 2? You have to know that cosine theta is the x part of the point. Then you can just look at the unit circle and see this would be happening when theta is pi over 6, or when theta is 11 pi over 6. Okay, so at this point we're doing things very similar to the first bonus question on the test we took. Okay, theta is still between 0 and 2 pi, looks like this. Here we just need to be comfortable with the fact that is going to operate the same way as this. It's just a quadratic. So we need to get it set equal to 0. We can solve a quadratic by factoring So this one would factor thusly. So then x would be 1/2 or x would be -1. So it would work exactly the same over here. 2 cosine squared theta plus cosine theta minus 1 is 0. You would have 2 cosine theta minus 1 times cosine theta plus 1. So then cosine theta would be 1/2 or cosine theta would be -1. This would happen at pi. This would happen at pi over 3 and 5 pi over 3. That was not good. Much better. First try. So you have that tool in the toolbox as well of recognizing it to be quadratic. Other than that, works pretty much the same as the other problems we've been doing. Get the trig function by itself, look at the unit circle to see when is cosine theta 1/2, when is cosine theta -1. Okay, so that's it for the trig equations. Now we're going to do this unit conversions problem basically. So you have a wheel with a diameter of 30 inches, rotates at 420 rotations per minute. What is the linear speed of the wheel measured in miles per hour? So this is really just a straight unit conversion. We're going to start by saying if the diameter is 30, then there are 30 pi inches in one rotation. Okay, then we know there are 420 rotations in 1 minute. Okay, and we just need to keep converting to get miles per hour. So 1 foot has 12 inches, and then 1 mile has 5,280 feet. So we got our miles. Now just hours, 60 minutes in 1 hour. So the minutes cancel. So we've got, what, 30 pi. Oh, I don't like that at all. Here we go. 30 pi times 420 times 60 over 12 times 5,280. So about 37.5 miles per hour. Okay, so just working in problems like this for practice and unit conversions. Also, it has to do with circles, which we're dealing with the trig functions, yada, yada, yada. So that's it for today. Learn solving trig equations, unit conversions. You've got your homework on Google Classroom that you can go and get and use the rest of class to work on that or the other older assignments.